Hello students, welcome to your and our beautiful channel Maths Nation. In my last class we have already discussed about the geometrical representation of quadratic polynomial. Today we will discuss more about this. In a quadratic polynomial we have already discussed there are two zeros. In a quadratic polynomial there are two distinct zeros. There are two zeros. Then the geometrical shape is like a parabola. Then the geometrical shape is like a parabola. Then the geometrical shape of a quadratic polynomial is like a parabola. Shape of the parabola depends upon the so many factors. Look at here. We will discuss these factors. What are these factors? Shape of the parabola is like this. It touches the x-axis at two distinct points when b square minus 4ac is greater than 0. When b square minus 4ac is greater than 0, then it touches the x-axis at two distinct points. When b square minus 4ac is equal to 0, then the quadratic polynomial is a perfect square. Then there is no two distinct zeros. Then at that time the parabola just touch the x-axis like this. A single point. This is a single zero. No two distinct zero. The quadratic polynomial is a perfect square. For example, suppose fx is equal to x square minus 6x plus 9. Here y equal to x square minus 6x plus y. It is a quadratic polynomial. Factorize it. Then this is x whole square minus 2 into 3 into x plus 3 whole square. This is a square plus b square minus 2ab. What is this? This is x minus 3 whole square. What are here two zeros? Two zeros are plus 3. Then it touches the x-axis at 3 0. No two distinct zeros, only at single point. When the b square minus 4ac equal to 0, then the quadratic polynomial is a perfect square. Then there is a single zero. Okay. Then understand? Then this is a single zero. Then the shape of the parabola touches the x-axis. Look at here. Suppose fx is equal to minus 4x square plus 4 minus 1. Here compare this quadratic polynomial with suppose fx is equal to ax square plus bx plus c. Here a is coefficient of x square, b is coefficient of 4x minus 1. b is coefficient of x and c is the constant. Compare these two equations. Then here a equal to minus 4, b equal to 4, c equal to minus 1. When a is negative, at that time the parabola is open towards downside. The parabola open towards downside. When the value of a coefficient of x square is negative, at that time the parabola open to downside. Here look at here. Here also this is minus 4x square plus 4x minus 1. If you factorize this is minus 4x square plus 2x minus 1. Then here minus 2x common. Then here 2x minus 1. Here plus 1, 2x minus 1. Then this is 2x minus 1, 1 minus 2x, sorry, 1 minus 2x. Then this is minus common, 2x minus 1, 2x minus 1. Here minus 2x minus 1 whole square. Here also no two distinct zeros, a single zero. In this case, parabola touches the x-axis like this, and the parabola, as the coefficient of x square is negative, then the parabola is open towards downside. Okay. Then when the coefficient of x square is positive, fx equal to ax square plus bx plus c. This is the representation of a quadratic polynomial. When it is important, when a is greater than 0, then the parabola is open towards upside like this. When the a is less than 0, then the parabola is open towards downside. When b square minus 4ac is greater than 0, then we get two distinct zeros. Then the parabola cuts the x-axis at 2 points. When the b square minus 4ac is equal to 0, then this is a perfect square. Then the parabola just touches the x-axis. There is no two distinct zeros, a single zero. Then it doesn't cut the x-axis at 2 points. Okay, this is important. Then next, now graphical representation of cubic polynomial. Now the graphical representation of cubic polynomial. Suppose fx, cubic polynomial can be represented as ax cube plus bx square plus cx plus d. Okay. Here let us take an example. Fx is equal to x cube minus 4x. Then y equal to x cube minus 4x. Then make a table. We erase and start from the new page. Suppose y equal to fx is equal to x cube minus 4x. Then we have to find out y for each value of x. It touches, this is cubic polynomial, it touches the x-axis at 3 distinct points. Here also, if this is x cube, this is x cube minus 4x. Here also, if this is a perfect cube, just like the quadratic polynomial, when it is a perfect square, we do not get two distinct points, we get a single point. Then when b square minus 4ac is equal to 0, then we get this quadratic polynomial is a perfect square, and we do not get two distinct zero, we get a single zero. Here the parabola touches the x-axis at single point. When b square minus 4ac is greater than 0, then we get that the parabola, we get two distinct zeros. Then the parabola cut the x-axis at two distinct points. When the coefficient of x square is greater than 0, then the parabola is open towards upside. When the coefficient of x square is less than 0, means negative, then the parabola open downsides. Understand those important points? Now come to the graphical representation of cubic polynomial. A cubic polynomial is represents as y equal to fx is represent as ax cube plus bx square plus cx plus d. Here is a cubic polynomial. Take an example. and find out the graphical representation of a cubic polynomial. A cubic polynomial has 3 distinct zeros, then it touches the x-axis at 3 distinct points. In the same way, if the cubic polynomial is a perfect cube, then we do not get 3 distinct zeros, then we get a single zero. At that time, it touches the x-axis at a single point. Okay, understand? Now, take an example and find the graphical representation of cubic polynomial. Then here y equal to x cube minus 4x. For every value of x, we have to find out the value of y. Look at here. This is x, this is y. When we take x equal to minus 4, then we get y equal to minus 48. When we take x equal to minus 3, we get y equal to minus 15. When we take minus 2x, then we get y equal to 0. Look at here. Then when we take x minus 1, then we get y equal to 3. Just extend the table. Then when we take x equal to 0, then also we get y equal to 0. Mark how many times it cut the x-axis. Here when y equal to 0, it cut minus 2, 0, 0, 0 means at the origin. Next, when x equal to 1, you get y equal to minus 3. Then when x equal to 2, you get 0. When x equal to 3, you get 15. Then when x equal to 4, it is 48. Look at here. How many zeros you get? 1, 2, 3. There are 3 points on the x-axis. Here it touches the x-axis as minus 2, 0. And 0, 0 means at origin. And at 2, 0. Look at here. What is the graphical representation of the cubic polynomial? You know, this is y, this is y dash, this is x, this is x dash, this is 0, origin. Then the graph will be like this. It got the x-axis at minus 2, 0. Then it passes through the origin. Then is like this. This is the graphical representation of a cubic polynomial. Means this is the graphical representation of the cubic polynomial x cube minus 4x. Suppose fx is equal to x cube plus 8 plus 12x plus 6x square. This is x cube plus 2q plus 3 into x square, 3 into x square into 2 plus 3 into x into 2 square. Look at here. This is x cube. This is 8 can be written as 2q. 12x can be written as 3 into x into 2 square. 6x square can be written as 3 into x square into 2. What is this? This is a cube plus b cube plus 3a square b plus 3ab square. Then what is this? This is a perfect cube. What? A plus b whole cube means x plus 2 whole cube. In this case, you do not get, then what is the value of x? X equal to minus 2. Here it touches the x-axis at a single point where this is minus 2, 0. Minus 2, 0. Then in this cubic polynomial, there are no 3 distinct zeros. It only touches the x-axis at this point, minus 2, 0. Then find out the relationship between the zeros of the coefficients of a polynomial. Then look at here. Suppose fx is equal to 6x square minus x minus 2. use middle factor factorizations. You can factorize this 6x square, 6 2 are 12 minus 4x plus 3x minus 2. Take 2x, then this is 3x minus 2 plus 1, this is 3x minus 2, then this is 3x minus 2 into 2x plus 1. Then what are the zeros here? Here zeros are, suppose alpha beta are two zeros of the quadratic polynomial, then here alpha equal to 2, then beta equal to minus 1 upon 2. Then what is the relationship between the zeros of a polynomial, quadratic polynomial? Alpha plus beta is equal to alpha equal to 2 upon 3. Sorry, alpha equal to 2 upon 3. Look at here. If 3x equal to 0, if 3x minus 2 equal to 0, then x equal to 2 upon 3. 1 0 alpha, then another 0. If 2x plus 1 equal to 0, 2x plus 1 equal to 0, then x equal to minus 1 upon 2, another 0. Then alpha plus beta is equal to 2 upon 3 minus 1 upon 2. The LCM is 6 and we get 4 minus 3, this is 1 upon 6. Alpha plus beta is equal to 1 upon 6. What is this? 1 can be written as minus of minus 1 upon 6. What is? Look at here. This is minus b upon a. What is b? B is the coefficient of x. A is the coefficient of x square. Then alpha, in a quadratic polynomial, if alpha and beta are two zeros of the quadratic polynomial, then alpha plus beta is equal to minus b upon a. Then what is alpha into beta? Alpha into beta is 2 by 3 into minus half. 2 cancel, we get minus 1 upon 3. What is, sorry, 8 minute, minus 1 upon 2, okay. This is minus alpha into beta into alpha into beta is equal to minus 1 upon 3. Minus 1 upon 3 can be written as minus 2 upon 6. Here what is minus 2? This is c upon a. Then in a quadratic polynomial, alpha into beta equal to c upon a. Alpha plus beta is equal to minus b upon a. These are the relationship between two zeros in a quadratic polynomial. Today this much. In my next class we will discuss about the zeros of relationship between the zeros of cubic polynomial and biquadratic polynomial, etc. In case of cubic polynomial we get 3 zeros, alpha, beta, gamma. In case of biquadratic we get 4 zeros. We will discuss this in next class. Today this much. Like, share, subscribe and stay tuned for the upcoming videos and press the bell icon to get the notification of the upcoming videos. Thank you, students.